All right. Draw a diagram. So, protons in a triangle. Here, let me share the screen. Okay. Let's get this right here. Proton. Is everyone here and working on it?
Yeah.
Cool.
1 sec, I'm pulling it up. Okay.
Dang, look at those art skills.
Yeah, I know, right? Oop, I'll make this line straight.
Beautiful. It's better than mine, and I was drawing it with a pencil.
I think that's probably why. We'll name this E1, E2.
What is a recitation group number?
44, right?
Yeah, it's
Yeah.
44.
3 on 1. Where's 1? 3. Okay. Have we ever had to put our recitation group number before?
No, I think
I
this
don't
is the
think so.
first.
That's weird.
Okay, so we have to calculate electric force for our concept.
Okay. Nice. So what are we doing? What is the kinetic energy of each proton? And then after that, okay.
I don't think they're electrons.
What? Protons? Ugh, come on.
Sorry.
They are all repelling each other. But we need to know, how are we going to know how much force they're exerting?
They're
I don't have the formula.
That would be the electric potential energy. So the okay, so we know that kinetic energy. Kinetic energy. We'll just put K plus the change in potential energy is going to be equal to 0. and that means kinetic final minus kinetic initial plus U final minus U initial 0. Kinetic final is 0. Sorry, kinetic final is not 0. Kinetic initial is 0. Potential final is 0. That equals 0. There you go.
So then we just go and do 1/2 mv final squared.
Mm-hmm.
Or
But how
Yeah.
fast are we moving?
How fast are we? What?
Are we comparable to the speed of light?
We're just doing very. Oh, that's right. Okay. I see what you're saying.
Well, we actually don't need to know. You know what? We don't do that. It's just we're solving for kinetic final, so we don't need to know.
oh, true.
So now we just go to potential energy, and potential energy, let's just say this is of the system, so it'd be 1/3 times, this would be the potential from, we'll do potential from 3 to 2, sorry, plus 3 to 1. Plus the potential from 2 to 1, because we'll find the, yeah, whatever, find,
Can't we just multiply all of them times? Or can't we just, what is it asking? What is kinetic? Can't you just do times 2 of one of the potential energies? Or are you doing it by 1/3?
Yeah.
Because if you were doing times 1/3, you'd have to go and find all of them.
Oh gosh. Gee, I wish I still had my notes. I fear they may be deleted into the ether.
Because with the square one, what we did was we had to do
Yeah, do you have
2 times the diagonals, but we don't have any of the diagonals, and then we just did 4 times aq squared over r. So wouldn't this just be, since there's only 2 forces acting on one of them, it's gonna be 2 times kq squared over r? Or over
Yeah.
d in this case?
Yeah.
That
Yeah.
seemed convincing.
Yeah. I vaguely remember doing that. 2 times whatever potential energy is. Yeah, that makes sense.
Which is just gonna be then a given k value, or 1/4 pi epsilon naught. I can get a,
That's 9 times e to the minus 9.
yeah. And then I don't remember what a proton is. It's like 1.9 something times 10 to the something. Charge of a proton is 1.602 times 10 to the negative 19. I'm going to square that. And then all of that's divided by e. Amazing.
I need epsilon.
What is the charge of a proton is... I'm sure I have this
I just read that off.
written down somewhere.
1.602 times 10 to the negative 19.
Fantastic.
Yeah, this is what I was talking about earlier.
What?
The force between two photons. For this formula.
I don't know what formula you're talking about, or like what. I don't. What were you talking about earlier?
Don't worry about it.
Okay.
So I guess I don't understand like why you multiply it by 2.
Oh, charge is plus E. So, oops. So.
Oh, we don't need that.
Also, yeah. So right now we're trying to find the total amount of potential energy that
Yeah.
something has, and the potential energy would be the potential energy, electric potential energy between E1 and E3, and then E1 and E2. That would give us the potential energy of E1. And since they're equidistant and similar in the same exact charge, we can take one of the potential charges and multiply by 2 to simplify things down, and that'll be the amount of energy that both of the protons add to the specific one. Does that make sense?
If you look, hold on, let me find where it is.
Because I know you're talking about, because this is one of the problems that we did, but it was like a square or rectangle or something.
Mm-hmm.
So I guess I'm confused because if we're trying to find the force of one proton, I think, wouldn't you just... I don't know. I'm still confused about the 2. Like, I get the distances are the same, but...
Okay, so since it's a triangle, you have, if you look at the diagram that we drew, you have two extra forces.
Oh, because there's 2
that are
forces.
acting on it.
Okay. Okay.
Should we be using vectors?
No.
No, we don't need vectors.
Because they're at an angle. They're not like directly in front of the proton.
I don't think we need to use vectors.
Yeah, no, that's okay because it's just the force. We're not looking. It doesn't ask for direction. It just asks for what the kinetic energy is, and you're gonna get the same amount of energy as long as there's the same amount of force being applied.
Okay.
Yeah. We're all set with that?
Should we add rest energy in, or do we not need to?
I don't think we need to.
Oh, because it'll be the same.
Yeah.
Okay. Wait. So that would just be, gosh, charge. They just want us to put E.
Yeah, I just did 2k E squared over D.
2k E squared.
K is the 9 times 10 to the negative 9th. I just wrote it as K.
K. K for kinetic energy.
K is just the constant 9 times 10 to the negative 9.
That's a little confusing.
Yeah.
Right. So I'm just.
This is like way back in the notes.
Okay. Are we sure that this is the answer? How confident are we?
Slightly confident. Oh, it's divided by R or divided by D, not R. Because it gives us D in the problem.
D. Fantastic. Okay. Okay. We're gonna go slightly confident. Actually, we'll go unconfident. I don't think they look at these.
What? They're gonna grade us like easier if we say we're not confident in any of our answers.
Why would they ask us how confident we are about these answers? Like, what? That doesn't. What, do they count us off for hubris if we get it wrong?
I don't know if they're hubris.
Chris, you were very quiet.
Oh, sorry. I don't know what the word hubris means.
Oh, it's like arrogance, overconfidence. Okay, justify the solution. I don't know. Create another problem.
You have 4 protons
Yeah,
in a square.
I'm going. Legit, I'm typing that.
How did they get 3 protons in an equilateral triangle?
They didn't.
Look, if they did that, I mean, they got some real research they can publish.
Wait, in this question, did it ask for? Okay, so it asked for each proton separately, right?
Each proton. Mm-hmm. All right, whenever you guys are done, let me know. Just kind of shout.
I'm ready whenever everyone else is ready. Also,
I'm
I'm ready.
This is. Audrey, are you ready?
Give me a couple more seconds.
You are A-okay. No need to worry about anything.
Come on, this is a hustle sport.
No pressure, no pressure.
This one, the next one, looks like something we did way before.
Mm-hmm.
Okay, I'm ready.
Okay. So problem 2 is what principles and concepts, circular motion.
I have a feeling we're gonna need energy principle, but
Actually, don't think we will.
really? Oh, bless. Okay.
We won't need what?
Energy principle.
Yeah, I don't think so. No, actually, maybe we can. What we can do is that we can calculate the potential energy when the block is at its highest,
Ah, yeah, you know what? That might be
and
easier.
then and then solve for kinetic energy at the bottom because
Okay.
there's no potential energy at the bottom.
Well, let's do that instead. Sorry, Elizabeth.
You're good.
No, it's like
What are yours?
I was gonna say it's like energy principle is gonna be really easy this time.
Yeah. I absolutely hate the energy principle.
I do too. Especially when it comes to springs, because they make it so... At least I'm confused with the whole spring thing.
Me too.
Wait.
Look, I'm in a perpetual state of confusion. So.
I cannot hear
Oh, never mind.
this at all.
He's just confused. He's here in spirit.
Name.
Okay, so we know that energy equals kinetic plus potential,
Mm-hmm.
and And then we know potential because it's mass times gravity times height. Wait, do we have any values?
Nope.
Okay, so it's all a bunch of variables. So then using that we can solve for kinetic and then velocity.
Nobody sees me copy pasting. There we go. There we go. What'd you guys get?
Still
Give me like
solving.
2 seconds.
No problemo.
Square root 2 GR.
Heck yeah.
Beautiful.
That sounds familiar. Square root 2g. Yep. Air resistance. That's kind of funny. Yeah.
That's on purpose.
The air resistance formula is the square root of 2gh minus the density, whatever, of the air. Should we account for air resistance? I think we should account for air resistance.
Yeah, I got 2GH. No, should we?
Yeah, maybe. There's air, and yeah, and since we're not actually solving this,
Technically, we don't need to use air resistance to solve this problem.
work of the air. I don't know.
Wait, yeah, why are we using air resistance?
Because we don't need to solve. We don't need air resistance to solve for the problem.
Because it's not like we're dropping a coffee filter.
Oh,
Sorry.
no, there is. Yeah.
Well, what does it find the block's speed? Well, technically, the speed would be different if we account for air resistance.
I almost said something. I almost said it's like a slippery
Wait,
or smooth.
air resistance is a force, right?
Mm-hmm.
So why are we getting it for a velocity?
Well,
Wait, yeah. No, wait, I don't think we need to account for air resistance because we're just focusing on energy. If we were doing it based off of the circular motion, I think then we would have had to.
Yeah, because the next one asks for what forces, what's the net force acting on the block?
I mean, we can just say no air resistance in part of our simplifications.
Oh yeah, like our assumptions.
Yeah. Approximations, no air resistance. That makes it simpler. Alright. I am recording, right? Okay, yeah. Alright, net force acting on the block when it's at location 2.
Okay, so this one.
Net force would be 0.
Yeah.
Wait, wouldn't it just be wouldn't the net force just? Never mind. Yeah, you're right. You're right. Sorry.
Because it's at the bottom of the ramp.
What? Force? Wait, what?
You have to prove this now.
We have to prove it?
Well, I mean, it's just to solve the problem.
We just
Or
Well,
we could just
find
say,
the net force. The net force is 0.
and I think honestly, what you just have to do is you have to do F net equals FG plus F normal, right?
I'm just gonna write out.
Are we sure this is right? Are we sure there's no net force?
yeah,
At the instance of point 2, there are no net forces.
there's no other significant interactions with the block.
Are they gonna yell at me for putting words?
Oh, by the way, you're kind of explaining why justifying your solution, so you can just take some of that and put it in the next section.
I could just copy paste it.
That's what I did. I just said the net force is 0 and then copy paste my explanation.
Oh.
Oh, and by the way, I'm sure they assume that you know that normal force cancels with gravity.
Oh,
So you can say, all you have to say is that normal force cancels gravity, instead of like explaining like how they're equal and everything.
yeah, might as well go verbose.
Yeah,
Especially,
you can.
especially since I already
You
typed
already
it
wrote
out.
it.
Yeah. Part B is force by the track on the block. Okay. Mass times gravity. Guys, how do you spell octagon? Wow, I'm down.
Yo,
Octagonagle.
oh god.
Wow, I'm very bad at spelling.
Happens to the best of us.
Oh my god. Oh my god.
What on earth is this
There we go.
question that we're typing up?
Here we go. What is the force of an amorphous octagonal prism sliding down a... Ooh,
I'm gonna talk about a skier going through a half pipe. I don't know about you guys.
I just said the same thing to the roller coaster.
Parker, what's a fancy word for parabola?
Quadratic.
Quadratic?
I feel like parabola is already kind of fancy.
Why do you need a fancy word for it?
Wait,
Because
what's...
I've lost my
okay.
will to live.
A second degree polynomial.
There we go. That's
There
what
we go.
I like that.
Oh my god.
I hate you guys.
I think you could go better than that. It's kind of chickening out early.
I actually like a fourth degree polynomial.
Square root of the square root of the 16th degree polynomial.
Wait, why did you say... Wait. Back up to part B. Why is the force on the track mg?
Because the force is at the bottom of the vertex of the parabola. The force is directly perpendicular to the track, which is pointing straight upwards, which is opposite of gravity, which is pointing straight downwards. And gravity is mass times gravity.
Okay, do we agree?
Which is a recursive definition, but ignore that.
Do we agree on this answer?
No.
No.
I don't know what you're talking about. What do you agree on what?
Do we agree on everything? Like,
Oh, whoops. Yeah, I think so. Okay, yeah, I think we're good. That only took us 33 minutes. Nice.
That's actually really impressive. I'm proud of you
Shortest
guys.
we've done so far.
That gives me an hour and 20 minutes to cry about physics now. That's great, guys.
Wait, before you do that, can you help me with the homework?
Alright, fine, I'll help you with the homework, but
Yes.
I need to fit in some crying tonight.
Okay, beautiful. Me too. I like to cry when I'm in the shower so that my face doesn't get all puffy.
You know,
I'm gonna stop
That's like
recording
pro
now.
tip for
at
me.
that point,